Yes, I will do. I guess you can see the presentation.
I can see the presentation. It's perfect. It's
So
full
that's
screen.
fine. So yes, good morning. From AT side to the presentation with the title Innovative Metrology Software Enables Super Fast 3D Evaluation. This sounds really great. But what we mean with that, maybe as you know, we are providing 3D triangulation sensors. So these have to be really fast. Then you have to get really fast an image out of the sensors. And then you have to start with the application for metrology. Therefore, you need some tools. No? And today I want to give you some impression how we do that, how we can do that with the software and the hardware from AT. So my name is Armin Jele. I'm a senior sales manager in Europe for AT. So I'm nearly 25 years in machine vision area, and a lot of the time for some big players and as well for system integrators. So and maybe since 10, 12 years, so 3D got more and more important. And we always were looking to AT because they have what I need for my applications, for my customers and projects in terms of more speed, of higher resolution, of more field of view, of dual light, and so on. And since 3.5 years, I'm part of AT, and now I have it, and I'm happy, and I can provide always the right sensor for the application. So a few words to AT. AT is a German company located in northern Germany. Maybe you heard some videos from our marketing team. Hello from Bad Oldesloe. This is between Lübeck and Hamburg. And yes, we are pioneers in infrared in 3D. Last year, we celebrate our 25 years anniversary. So really a long history. And now we are more than 50 people, and we are developing, producing, and selling special cameras in two areas. One is infrared. If you have an application for infrared, don't hesitate to contact directly. But today we want to talk about our 3D sensors, and we only have triangulation sensors which you connect to the PC. But a big portfolio and some really good benefits for our sensors. And we always say if customer is using AT, they will always use AT because we always had maybe the fastest sensors, and we go a step higher. It's really a revolution for the triangulation sensors with our WARP. It's standing for Widely Advanced Rapid Profiling. What this means, I will explain in the next slides. We have a big portfolio and images from 1280, 2000, 3000, 4000 pixels per profile, and also different sensors and with different lasers, laser glasses, laser wavelength, and also depth of field of the laser line thickness, all depending on the application. So we have a big portfolio, and you see on the right side, maybe the red camera, it's just a 3D camera where you need a separate laser and to do the calibration by your own. But then we have a big portfolio of standard sensors, so nearly 40 sensors multiplied by different laser options. So these are more than 200 different sensors. And out of these sensors, we launched in the last week some special series. So this maybe is called ECS, standing for efficient or economic compact sensor. This means this is more or less the entry level, and we use the sensor with 2000 pixels. Still not high speed, but fast enough, a lot of applications, and only with a laser, with the red laser, 660 nanometers and 2M. This means also laser safety is not a big issue. And this is maybe especially for markets like food and beverage, logistics, robot vision, where you need maybe more than one sensor, a multi-sensor application. So the costs are really important to take it. And also, regarding the application, we talk about more or less millimeters, not micrometers. So this is the entry level. And then I go directly to the high-end level. And last year, we launched our new imager developed by AT. It's called the C6 3070, means with 3070 pixels. And if you look to the standard, and normally a 3D sensor has an imager, and you transfer the complete image, means all pixels from the imager to the FPGA. We go another way, and with our 3070 imager, there is a pre-processing. Means, you see it maybe in this graphic, we just detecting the laser line directly on the imager. And then we transfer only a few pixels around of this laser line from the imager to the FPGA. This means maybe 10, 20 times less information. It's also 10, 20 times faster. And with this imager, we achieve up to 44 kilohertz. And with this imager, and in combination with the new 6 FPGA, which have double speed for the high resolution sensors, and in combination with the new I/O board, which have 2.5 and 5 gigabit per second, to transfer this much of information from the sensor to the PC. That's what we are calling warp speed. And as I said, yes, it's standing for widely advanced rapid profiling. But this was from low end to high end. And we also have some special series. We said, yes, there are a lot of standard components and standard sensors. If this is not flexible enough, we have our modular compact sensor, and then all of the imagers and the lasers and so on. We can put these components together to have really a customized sensor, like you see on the right side. This is a dual head. There's a sensor module, a second sensor module, and in the middle, in between, there's a laser module. And as I said, this is a customized sensor. This sounds expensive, but it's not. Means we can have no minimum order quantity or additional engineering costs. And at the end, you have a MCS configurator. Then you insert all data what you need in terms here, the laser, the working distance, the field of view you need, the triangulation angle, and then there's a sensor coming out. Has at least two modules. One is the sensor module with the imager, the optics, Scheinflug, and mirrors. And the second one is the laser module. And depending of the numbers which you insert, there could be maybe no link module in between, a small one out of metal, or a big one with a laser tube, carbon tube. So at the end, you get really an optimized sensor for your application. Means the best solution what you can get. And as we see it in a lot of applications from customers, they have maybe a sensor, the field of view is not big enough, and they go maybe in the far field. Yes, okay, you can do that, but you can imagine you are out of the focus. Means also the results are not really optimal. So this is the MCS, and out of the MCS, we made some special sensors called XCS. It's really standing for maybe extreme, excellent. And this is really for a performance. So we take an MCS with a high resolution with the 3000 or 4000 pixels and bring that on a really small field of view. It's from 48 to 53 millimeters. And this is especially done for the electronic markets. Yeah? For example, you see on the left side, it's for pin grid area or ball grid areas, the BGA, or for pin inspection, where you need really high resolution, you need extremely speed. And in the past, maybe triangulation sensors were not fast enough for these applications. Now we can do that. And yes, you can use for high speed, you use the 4070 warp speed. And this is the imager. And also you need a really good laser line projection. Therefore, we need a special blue laser with a clean beam technology. And at the end, you get a really thin laser line to get really good results and to get a lot of information, for example, from these pins. So this should be a short impression to see what sensors we have. This is the first part of super fast to get the images out of the sensors. And in the past, yes, we just provide a sensor. And I always see a 3D turnkey solution is like a puzzle, a complete puzzle. And we had one puzzle part. This is the image. The 3D image, yes, for sure, it is the most important part. It's because if you cannot see what you want to measure, if you cannot see in the image what you want to inspect, which defects, the best tools will not help. So, but in the past, then you send the images to maybe to your own software, to third-party vision libraries, and then you start to develop your application. Since last year, we provide a solution package. So you not only get the image, you can also start with processing. You have the calibration in, you have vision tools in. Yeah, you can do the own application with our software, with our hardware. You still need a PC. You still need experience in 3D vision. And yes, it's a PC-based solution, but it brings you really, much more benefits. And to introduce the solution package, it has for sure the software, the firmware for the sensors. It has our SDK. Maybe customers, you know that, is the CX-Explorer. There are a lot of features in, a lot of parameters, and at the end, you get really robust image, you get a really robust application, but it seems a little bit complicated. So we announced the metrology package, and this metrology package is much easier. There's a much easier graphical user interface, as you see maybe like here. You see in this MetrologyExplorer all sensors in your network. We directly connect a 3D sensor, and then you have all parameters which you need to acquire an image, like exposure time, gain, like triggering, you can see the encoder signal, how many profiles you want to acquire, and then it makes it much easier to get an image really fast from your part. And just you said, we say within 10 minutes, you get a first image. So this is the image, and then you start with development. We have a lot of samples, like here, maybe so for pin inspection. You can use this sample and then starting to develop your application with your scripting. You see it in this example. But first of all, yes, you get the image, and this is one image with our XCS, with this fast sensor, and with the small scripting. And here you see the BGA, the ball grid areas. Another example is here with a part and the pin inspection. And here we still used one of the sample scripts. No? Then you see here exactly the measurement and the height of these pins. So this is the next step, get a fast image, to get an image in your PC, and then you start with the processing with this MetrologyExplorer. And yes, super fast prototyping and development. We have a lot of 3D tools in it. Then you start the measurement and the metrology application. If you want to do more scripting, if you need the source code of this complete application, for example, you want to put this complete source code in another software in your machine, or you want to use it for deep learning or TI, then you can do that, and therefore you need a development license. But we also have things which are really important, like the calibration. So calibration, we have factory calibrated sensor, but this is along the laser line, means lateral. But also to mount a sensor with 90 degrees in 3 dimensions, it's not easy, but you don't take care about it. We take a calibration target under the sensor and you do the calibration, and then it's fixed, and don't care if it's not exact plane or not. Or in this application, you see there are maybe 2 sensors. We have it as a dual head. You have two sensors, you have 2 images, and then you have to put these images together. Or in this case, you see 2 sensors as a V with 2 different laser columns. The color sets do not influence each other. So we get 2 images. You see one as mounted as a V, and with the calibration, the multi-sensor registration of our metrology package, you quite simple get one exact point cloud out of, in this case, 2 sensors. It could be 4 sensors or maybe more. But this is a really important point, and everybody who is doing software programming and what I talk about, if you talk about calibration, or maybe to get the coordinate system of the vision sensor to the robot, it could be really, really complicated. So you can do it by your own, or you can test it and use our software and see if it's bring you some advantages. Then you can use it. If not, you can do it by yourself. And we also have, since a few weeks, also some calibration targets in different sizes. So you can buy it from us. And then with this target, with the software, with the calibration, with the tools what we have in the metrology package to get easy an image, it's really, really fast to get an application out of that. But as I said, you need the experience in that. You can use this software to do the application really fast. And yes, you can believe it or not, but we make it offer to you. You can test it by yourself. We can provide you a load sensor. You can download the software and test it by yourself if I'm right or not. So, but we also have some nice application stories. Yeah, very often we are not allowed to show that, but it's one application from SenseWork. We talk about a SET scan. It's a really big container, I would say, with really accurate mechanics and laser linear axis. And here you can see there are 4 MCS, modular compact sensors, optimized in the field of view, in the laser distance, triangulation angle. We choose 2 different laser colors, also with maybe nearly the same laser line thickness, with the depth of field of the laser to get really good results. And then out of these 4 sensors with the metrology software, you get 1 point cloud out of 4 sensors. This point cloud will be compared with the CAD data, and then you can maybe on some special areas, some special points you can do the measurement and do the comparison, and if this all in green, it's all fine. So they're also using this calibration plate, little bit bigger, with the spheres to do the calibration, the multi-sensor calibration and at the end you get really a good accurate result in the metrology application. This inline metrology, yeah, today it's until 8 seconds. It's they are using here in this case the former sensors from C5. With the new C6 generation, it's more than double speed, so you need only 4 seconds for that. Another application from automotive. So you see here this car bodies or car parts. You see here one sensor is going up and down, inspecting a door, do the measurement, do also surface inspection, gap and flash. So the complete car door is inspected with a optimized modular compact sensor. And also for the complete car body, you see here five robots with MCS sensors and doing the inspection, the inline inspection of a complete car. Means here 100% control, not to put this body in the offline to the lab and maybe do the measurement. You can do it really inline, sorry, and this 100% of all cars and car bodies. Another application from our partner in Germany, company AKU. This were some inspection of 360 degrees inspection of some gearbox parts and metal parts. In this case, you see in the image, this is the calibration target, what they made there for. And you need really, without occlusion, the complete image around 360 degrees of this part. Therefore, they're using 3 modular compact sensors as dual head. Means they have six images. And then with the software from AKU, the framework Vision Manager, they do the point cloud out of 3D, out of 6 sensors, sorry, and get one point cloud. And this point cloud can, the application can be done with different third-party libraries like Vision Pro from Cognex or with Halcon, and then you can do the complete application out of that. So this is more or less the end. It was really fast to give you impression that we have really fast sensors, that we have some really good tools. You can use it or not. If you need it, it's really helpful. And really to get an easy 3D metrology application in a short time. And as I said, you can test us, you can send us a specification, we can talk about the sensors to choose the right sensor. Yes, don't hesitate to contact us. And now, if you have some questions.
Now is the time for the question. And I've got a question. No, here's a question from the audience. Is it working on glass bottles?
We do application on glass bottles, but glass is is special. Yeah, we have a tool. It's called multi-peak. Means you can handle up to 4 peaks. And if you look, for example, to glass, to flat glass, you get two peaks. You get 2 laser lines. You can measure the thickness. But 3D, this is on flat. But if you talk about really 3D glass, you need some special tilt, some special angle for that. We have to test it. You can do some applications, but not all. Yeah, we have to test it. But if you want maybe to turn the glass around, maybe this is possible. But you have to see what is the application, what you really need to do.
And does the warp profile system generate real-time profiles at 44 kilohertz?
Yes. So we have always some nice tools, some speed calculators, and standard tools. You have a set range, and you say what is the set range, how many millimeters. Then you see how many rows you need for that, and this is influencing the speed for sure. You see exactly which kilohertz you can achieve. For the warp, it's a little bit different. Yes, you don't need rows. You go along the laser line and have the pixels. So.
I see
and
some
therefore, we also have a speed calculator. Depending on the application, we can calculate it really accurate.
A lot of questions arising. So if you have questions, please use the chat or the Q&A. Is it possible to use only the warp camera and technology with our custom laser, or the system must be together laser camera?
So we have a camera also with the warp with 3070 imager in. Then you can use your own laser and do the calibration by your own. This is just a camera. But the rest are the compact sensors. Yes, there's laser and camera in one housing and factory calibrated. But it's just a camera, yes, it's possible.
And can we scan transparent objects without applying spray?
we are machine vision, means we have to test it, yeah, depending on a lot of things. And also we have some nice tools like this multi slope, yeah, to have a good laser line independent if it's shiny objects or dark objects. But in the end, a test will be helpful. Yeah, the rest is maybe, yeah, look to the glass bowl.
And what accuracy can you reach on a 360-degree measurement, and how accurate is the calibration?
A lot of questions, and also we need more specifications. Means, yes, what is the field of view? Now, how many millimeters? You know, we have a lot of pixels, up to 4,000 pixels. Then you see what is the resolution. Accuracy, we say we have to need 5-10 times more resolution to get this accuracy. So therefore we need the specification, then we can calculate it directly and exactly, yeah.
Two questions, then we have a Q&A session for the 3D scanner part. But is the camera a 10 GBE, GigaVision or Coax Express?
We are going a GigaVision. Today we have just 1 gigabit per second. In the future we'll have 2.5 and 5 gigabit, and this is enough to get the warp speed, the images out of that. And therefore we also have the calculator to see, yes, the camera is fast, but maybe too fast for 1 gigabit. But yes, in the future, this is what we call warp speed. We need the right image with 2.5 and 5 gigabit.
Dirk, I'm sorry, one last question. What accuracy we can get for inner diameter inspection of 30 millimeter size?
30 millimeter size, also depending on the field of view. And yes, if you use the 4,000 pixel sensor, you can divide the field of view by 4,000, and then you get the resolution out of that. But also always important to get maybe the specification, then we can choose the right sensor. We can get all numbers of the sensors and resolution X, Y, Z, and also the speed.